So we're still going to be multiplying. We're going to multiply polynomials, except we're going to look at special ones. Now, if you want to learn the rules for special polynomials, you can do probably most of it in your head. If you don't want to learn the rules, you can still use the box method and you can still distribute. Okay? So let's first look at, we're going to multiply something that's going to look like a plus b squared. Now, before I do anything, with my fingers crossed, how do I write a plus b squared? What do you think I'm going to do first? No. What do I do with a plus b squared? What does that mean? You write it twice. It means a plus b times a plus b. Remember when we were talking about exponents and I said you cannot distribute an exponent in if there's a plus or minus? This is where it's going to come into play. Okay? So let's actually look at an example. So if I give you x plus 4 squared, x plus 4 squared means x plus 4 times x plus 4. Okay, you write it twice. You cannot distribute that exponent in. What's special about this one? Huh? Go ahead. Okay, so you can't distribute that to him, but what's special about this? They're exactly the same, right? So these are exactly the same. Can you multiply them? So let's multiply. I'm going to just distribute because I don't really want to draw a box right now. So x times x is x squared. What?
I appreciate you sharing around.
Yep. X times 4, 4x. So I took the first one and I distributed to both terms. I'm going to take the second term and distribute to both terms. 4 times x is 4x. 4 times 4. So this middle term here is always going to be the same if these are exactly the same. So if my factors, x plus 4 and x plus 4 are exactly the same, then those middle terms are going to be exactly the same, giving me x squared plus 8x plus 16. So really what's special about this one is how you have to write it. Okay? X plus 4 squared, you write as x plus 4 times x plus 4. That's the biggest thing. You cannot distribute that exponent in. Are you okay with that? Okay. What about this one? What if I tell you I want you to multiply a minus b squared? How am I going to write that out?
A minus b times a minus b.
Okay, good. So it doesn't change because there's a subtraction sign. It's exactly the same. So a minus b times a minus b. So why don't you multiply 2x minus 5 squared? So take a second and multiply 2x minus 5 squared. Okay. Hopefully you started by writing 2x minus 5 times 2x minus 5. From here you can do the box or you can distribute, whatever one you prefer. If I distribute, I'm going to do 2x times 2x, which is 4x squared. And 2x times negative 5 is negative 10x. Because these are exactly the same, what do you know about this middle term? It should be exactly the same. Negative 5 times 2x is negative 10x. Negative 5 times negative 5 is a positive 25. Final answer, 4x squared minus 20x plus 25. Okay. So these ones are special because of how we have to write them. The next one's super special and going to be one that you love if you can memorize the rule. All right. We're going to multiply a plus b times a minus b. We're going to multiply a plus b times a minus b. And before we do this, let's talk about what we notice. What do you notice about this problem? Okay, I didn't hear a word you said because I can't hear very well. One person. Brooklyn, what'd you say? Okay, so you have a plus and a minus, but everything else is the same. Do you notice that? Okay, this particular one is called difference of squares. It's called difference of squares. We are going to use this a lot, especially in the next unit. And if it's something that you can recognize, the work for you is going to be easy on this particular problem. Okay, I will tell you right now kind of what the trick is, but your final answer will always be whatever a squared is minus whatever b squared is. And I'm going to show you how that actually works. Okay, so this is going to be your final answer, whatever a squared is minus b squared. So if we look at x plus 3 times x minus 3, for instance. Really, all you need to do, and this is where people get confused, it has to be exactly the same with 1 plus and 1 minus. So everything's the same except the plus and minus. Okay? All you're going to have to do is multiply the first terms. X times x is x squared. And multiply the last terms. 3 times negative 3 is negative 9. Now I'm going to show you why that works. My concern with showing you this is some people are going to be like, sweet, I'm going to do this all the time. It doesn't work all the time. Okay, so let's see why it works here. If I distribute like normal, so pretend I didn't know the rule and I'm just distributing. X times x is x squared, right? X times negative 3 is negative 3x. You with me? Okay, now let's do the second term. 3 times x is positive 3x. 3 times negative 3 is negative 9. So why does it work that I can just multiply the first terms and just multiply the last terms? If you look at this, why does this work? The middle terms cancel, right? Because one's positive, one's negative. So all I have left is x squared minus 9. If it's going to confuse you, don't do the trick. Distribute or use the box. If you notice the trick and you don't want to do the work, you do you. Does that make sense? It will not always work. It has to be exactly the same with 1 plus, 1 minus. Okay? So try this one. Actually, I'm going to give you 2. Oh, you can't see both of them. Okay, so if you understand the trick, use it. If you don't and you know it's going to confuse you, box or distribute. So again, you use the trick if you see it. If you don't, distribute, use the box like normal. For number 2, if I multiply the first terms, 2x times 2x is 4x squared. Last two terms, 7 times negative 7 is negative 49. Okay, real quick, let's break down why it means difference of squares. So what does difference mean?
Opposite.
In math? Subtraction, right? The difference of something is subtraction. So my final answer is subtraction, right? And then squares are like 16, 9, right? Because what's the square root of 16? 4. What's the square root of 9? 3. What's the square root of 36? What's the square root of x squared? X. What's the square root of 4x squared? 2x. What's the square root of 49? 7. Okay, so all of these are perfect squares. There's a subtraction sign in between, and they're all perfect squares. For number 3, you should have gotten y squared minus 64. Okay, are we okay with that? Everybody understands that this only works if they're exactly the same with a plus and a minus. If they're exactly the same and they have the same sign, this doesn't work. We get that? Okay, someone's not listening and someone's going to get it wrong. I don't know who's not listening, but if it's you or your neighbor, wake them up. All right. Questions, comments, concerns?